Hey guys, welcome to Success Chamber. And today we shall be starting a new topic, that is sequence, series, and progression. So we're going to start a new topic, that is sequence, series, and progression. Now this chapter is very important from CAT perspective and for other MBA entrance exams too. Now you have to understand two terms here. What is a sequence and what is a series? So you can take any arbitrary set of numbers. Suppose I take 2, 4, 9, 11, 21. It's very difficult to establish a relationship between these numbers. Like you cannot say what will be the next number. It's very difficult. So that won't be a sequence. So a sequence is a set of a number which goes according to a particular rule. So if I take it like this, 2, 4, 6, 8, obviously you can tell me that the next number will be 10. So what I can directly tell from here is that each term can be represented as 2n, if you see here. So if you put n equals to 1, you get 2. If you put n equals to 2, you get 4. So similarly, if you put n equals to 5, you get 10. So a set of numbers which follow a particular rule will be called a sequence. Likewise, if you have 1 by 1, 1 by 2, 1 by 3, so on. So the next number you can easily tell it to be 1 by 4. So what I can say is that each term can be represented as 1 by n. If you put n equals to 1, you get 1 by 1. N equals to 2, you get 1 by 2, and so on. So it has to follow a particular rule. Now if the terms of a sequence are added or subtracted or multiplied or any of the operation is done on the terms of a sequence, that becomes a series. So if we have 2, 4, 6, 8, or let us take it to be A1, A2, A3 and A4 are the terms of a sequence. So this is a sequence, right? If I add these all terms, this becomes a series. So this denotes a series. So any of the operations, let it be multiplication 2 or minus 2 or division 2, any of the operations is being done on the terms of a sequence, it becomes a series. So this was about the definition of sequence and series, which should be clear in your mind. Now moving on. So here we have to study. So what we have studied till now, we know that a sequence is a set of numbers which follow a particular rule. And here we have to study three kinds of sequence. And these are special types of sequence. So progression is our special type of sequence. Special type of sequence. So sequence is a bigger set and progression is one part of it. So here we have to study three sorts of progression. Those are special type of sequences. You should keep in your mind that they are also sequences. The first one will be arithmetic progression. Let us start with arithmetic progression. Now what do you mean by arithmetic progression? You have a set of numbers, that is A1, A2, A3, A4, A5 and so on. And you find that the difference between the two numbers always remains a constant. Always remains a constant. Let us say it to be D. Then this kind of a progression will be called arithmetic progression. So the difference between two numbers should remain a constant. Let us take an example. Suppose I have 2, 4, 6, 8. So what I find is that the difference is always 2. So that will be called an arithmetic progression. So let us suppose I have n numbers. So suppose I'm having n numbers, A1, A2, A3, A4, so on up to AN. And it's given that they are in arithmetic progression. So what can I say is that the difference between any two numbers, any two consecutive numbers, always remember, will always be a constant. Let us say D. Now this D is called common difference. This D is called common difference. So can I say it like this, that A2 will be equals to A1 plus D. Similarly, A3 will be equals to A2 plus D. A3 can also be written like, if we replace A2 from here, I can write it as A1 plus 2D. So if you extend this further, you can say that the nth term, this denotes the nth term of an AP, can be given as A plus n minus 1D. See, the third term given as the first term plus n. What is n? The term that you want to find out, minus 1 into D. So this is actually the first term, the term you want to find out, and this is the common difference. This is a common difference, that is the difference between any two consecutive terms. So if I have, suppose, 2, 4, 6, 8, 10, and somebody told me to find out the 20th term of this sequence. So I'll directly write the formula T20. What is the first term? That is 2, plus which term I have to find out? 20th minus 1. What's the common difference? 2. That will come out to be 2 plus 19 into 2. That will be equals to 40. So this is how you can find out the nth term of any of the AP. Now there is another concept called the last term. Now last term is actually the last term, this one, that is the nth term. So I can say directly like the last term will be equals to the first term, that is A1, plus last term will be the nth term, so n minus 1 into D. So the last term will be this thing. Right. Now the sum of all the terms of an AP, suppose there is an AP consisting of n terms here. So sum of all the terms of this AP is given by n by 2 2A1, that is the first term, plus n minus 1 into D. Now this is also written as n by 2 into first term plus last term. So this thing you should remember. Now this can be easily derived. Easily. Likewise, I can write A1 as A1 plus A2. In place of A2, I can write A1 plus D, plus in place of A3, I can write A1 plus 2D. So on. I will write the n terms and will add it up. We'll get this thing. It can also be written like n by 2, the first term plus last term. So these are some of the formulas which are actually very important. So actually dealing with questions of AP. So let us take a small example. Suppose it's given that minus 7, minus 2, 3, 8, 13, so on, and it's a 30 term AP. Suppose it's a 30 term sequence. Suppose it's given 30 term sequence. So the first thing that you will do is that you will find out whether it's an AP or not. And if you find a common difference, it's always coming out to be 5. So it's an AP. And the first question is that find out the 20th term. So that will be first term plus 20 minus 1 into 5. Common difference, the next term minus the first term. That will give you minus 7 plus 95. That will give you 88. Now second question is find out the last term. So the last term will be the 30th term. So this is minus 7 plus 30 minus 1 into 5. Minus 7 plus 29 into 5. That will be 145. That will give you 138. Now suppose sum of 20 terms. Suppose sum of 20 terms of this 30 terms wala AP. So write 20 by 2 into 2 into minus 7 plus 20 minus 1 into 5. Now sum of all the terms, so that means as 30. Now that can be done by both ways. Either I can use this formula. So if I use this formula, in place of 20 I will place 30, or I can use that formula also. 30 by 2, first term, what is that? Plus 7 minus 7 plus the last term. Last term we have already found out, 138. 138. Both the formulas will give the same answer. Right. So in this way we can find out any of the term, you can find out the sum of the terms, you can find out last term, you can find out common difference in case of an AP. So these are some of the basic things that are inside the mind and actually deal with questions of AP very easily. Now, some basic things are important, like cover up those things. Sometimes is inside the question. Having said, like this is a concept, like suppose I say that A, B, C are in AP. If I say A, B, C are in AP, that implies that B is the arithmetic mean of the other two, that is A and B, E and C. So if this tell you that let's take A, B, C are in AP, find out the arithmetic mean of A and C, then that will be B. So can I say it from here that if A, B, C are in AP, so B minus A will be equals to C minus B. Find from here, B will come out to be A plus C divided by 2. So this is important. Now the next sort of a question is there is that suppose you have two numbers A and B. You have two numbers A and B and they are not in arithmetic mean. So you have to add n arithmetic means between A and B. If you have to add n arithmetic means between A and B, let us suppose those n arithmetic means are AM1, AM2, AM3, so on up to AMn. So if I am inserting n arithmetic means between A and B, this means that A, AM1, AM2, so on up to AMn, and B, this entire sequence is an arithmetic progression. This entire sequence is an arithmetic progression, right? So if this entire sequence is an arithmetic progression, can I say from here that B is the last term, that will be equals to first term plus, how many number of terms are there? N plus 2, you can see n arithmetic means plus 1 plus 2. So n plus 2 minus 1 and common difference. So what I can find out from here that D will be equals to B minus A divided by n plus 1. So can I say that the first arithmetic mean between A and B will be A plus D? The second arithmetic mean will be A plus 2D. Similarly, the nth arithmetic mean will be A plus ND. This is simple. So suppose you are given 2 and 8. So insert 3 arithmetic means between 2 and 8. So what you can say is that 2, A1, A2, A3 and 8, they are all in AP. Now if you remember this formula, it's okay. If you remember this formula, you can directly tell that the common difference will be equals to B minus A, that is the last term minus the first term, that will be 6, divided by n plus 1. N is what? 3, 4, that will be equals to 3 by 2. So you can tell that A1 will be equals to 2 plus 3 by 2. A2 will be equals to 2 plus 3 by 2 into 2. And A3 will be equals to 2 plus 3 by 2 into 3. Same, applying the same similar formula. So in this way you can insert any number of arithmetic means between two numbers, and this becomes very important from competitive exams point of view, because this question has usually been asked many a times inside different exams. Now there is another small thing that you should all know is suppose you have been given any number of terms and they may not necessarily be they may not necessarily be in arithmetic progression, and if you are required to find out the arithmetic mean of these numbers, so that arithmetic mean is given by divided by the number of terms. So this is one thing which is actually very important that you should be knowing. Okay, now the next we shall be taking up some of the properties of arithmetic progression. So some of the properties of arithmetic progression we shall be taking up. Now let us suppose properties. Now if you have an arithmetic progression a1, a2, a3, so on up to an, and if you add and subtract a constant term to all the terms, it is still remain in AP. So if I add suppose k, it is still remains in AP with the same common difference. If this is D, then this will also be D. So if you add and subtract a constant term, the resultant sequence will also be in AP with the same common difference. Now similarly, if you multiply all the terms by a fixed constant, then it again remains in AP, but in this case the common difference will be k times the earlier common difference. The common difference will be k times the earlier common difference. Now the third property is, if you have two AP, suppose this one is one AP and this one is another AP, and if you add the terms, so you get a1 plus b1, a2 plus b2, so on, an plus bn, this also remains in AP with common difference now being equals to, suppose its common difference is d1 and its common difference is d2, so the common difference will be d1 plus d2. And if you subtract, the common difference will become d1 minus d2. Okay, so this was about some of the properties. Now we shall cover one or two more properties here. We shall see one or two more properties here. Now one thing you should understand is that if suppose a1, a2, a3, a4, a5, you have taken two AP, suppose a1, a2, a3, a4, a5, a6. So one AP is having odd number of terms, another AP is having even number of terms. So in case of odd number of terms, the summation of the extreme terms will all be same. That is, I can say a1 plus a5 will be equals to a2 plus a4, and since a single term is left, that will be equals to a3 if that is divided by 2. So if we take the mean of the extreme terms starting from beginning to and the end, it will all be similar to the middle terms. Now in this case, as you can directly see here, a1 plus a6 will be equals to a2 plus a5, a3 plus a4 divided by 2. Right, so this is one thing which is very important. So if somebody asks you what is the arithmetic mean of this arithmetic progression, so you can directly tell that it will be equals to a3 or a2 plus a4 by 2 or a1 plus a5 by 2. Similarly, in this case, you can find out the arithmetic mean of the AP. You can give by either of these three terms. Now, from this thing, suppose the arithmetic, these all comes out to be AM, suppose AM. So the sum of 5 terms will be nothing but 5 into AM. So what I can say is that the sum of n terms of an AP, so we already have got two formulas. Now this formula will tells that will be equals to n into AM. AM is the arithmetic mean of this arithmetic progression, and that can be found out by adding the extreme terms divided by 2. Extreme terms divided by 2, any of the two extreme terms, starting from beginning and end. So this becomes very important. Right. Now one last thing that I would like to sometimes inside the question you are supposed to assume terms in AP. So if they ask you to find out 3 terms in AP, so the 3 terms can be, if you have to assume 3 terms in AP, you can assume it like this: a minus t, a and a plus t. If you have to assume 4 terms, We have to assume it at a minus 2d, a minus t, a plus t, and a plus 2d, and so on. So this is the thing which is important. Now there are some of the formulas here, that is if you have to find out the sum of n natural numbers, so the formula goes like n plus 1 divided by 2. So the first n natural numbers, to find out the sum of squares of first n natural numbers, formula goes like n plus 1, 2n plus 1 divided by 6. If you want to cube sum of cubes of first n natural numbers, it will be n plus 1 divided by 2, the same thing but the square of that. So we have completed arithmetic progression. We shall be taking some examples, and then after we will complete geometric progression and harmonic progression in the next class. Stay tuned to Success Chambers and happy learning.